fifth grade Cougars. I enjoyed learning about space with you, and now we're going to come a little bit closer to our own planet, planet Earth. So, we looked at the sun, we looked at some moons, we looked at space, but there's something special about Earth. It's the only place that we've found so far that has life. So there are three things that are important in terms of having life on Earth. So the first one is location. Earth is in the perfect location. It's not too close to the sun so that all the water would evaporate. It's not too hot. It's not too far away from the sun so that liquid water would be in a frozen state. We say that the Earth is in the Goldilocks zone. It's just right. The second thing that makes life on Earth possible is water, specifically liquid water. And again, that goes back to location. Because we're not too close to the sun, the water doesn't evaporate. And because we're not too far away from the sun, the water doesn't stay as a solid. So liquid water is really important for life. Liquid water is important for chemistry, and we're going to talk about that later on in the year. And the third reason that we have life on Earth is that we have an atmosphere. And this atmosphere protects us from bad things in space. So right now, we're going to talk a little bit about the atmosphere. One of the reasons we have life on Earth is because we have an atmosphere. And the atmosphere is this wonderful blanket that protects us from dangerous things in space. And the atmosphere has like a series of layers. Now it's not like a layer of cake and frosting because they kind of blend into each other. But we can say that there are these specific layers. The layer that's closest to the Earth is the troposphere. And all of the weather that we have on Earth takes place in the troposphere. The next layer is the stratosphere. You guys have heard that. The next layer is the mesosphere. Then comes the thermosphere. And then after the thermosphere comes the exosphere and space. So when we talk about the atmosphere, we think of this big, huge, thick blanket of air that's protecting us from space, right? It's protecting us from the solar wind, it's from charged particles, it's protecting us from asteroids and meteors. But let's just see how thick that blanket really is, okay? So down here at the bottom is the troposphere. All weather on Earth happens in the troposphere, and it's only 9 miles thick. That's it. After the troposphere is the stratosphere, and it goes from 9 miles up to 31 miles. Not very thick. Then there's the mesosphere, and that goes from 31 miles to 53 miles. Again, this is 53 miles. It's not very far above the surface of the Earth. And in the mesosphere, that's where all those meteors are burned up because of friction. It looks like a shooting star, but it's really a meteor or some type of space rock or something coming through the mesosphere, getting hot because of friction, and it looks like a shooting star. Then look at this enormous section of the atmosphere. This next section is called the thermosphere, and as you can probably guess, it's the hottest layer of the atmosphere. In the thermosphere, around this area, is where the aurora borealis takes place, and that's near the poles. In the thermosphere is where the International Space Station is. So it's not out in space, right? It's actually in our atmosphere. And at the end of the thermosphere, it's 347 miles. That's the top layer of the thermosphere. Then it's the exosphere before it gets to space. And space starts about 375 miles off the surface of the Earth. Boys and girls, that's just about as far as it is to San Francisco. It's not that far when you think of that thin layer of air is protecting us from harmful things in space.
The atmosphere is made out of a mixture of gases. And as I said, it goes all the way up to 375 miles above the surface of the Earth. All of that gas starts pushing down on each other. Even though it's still a gas, the molecules start building up. It's like a big layer. It's like a big, huge cake of gases. And the bottom layer of gases are compressed the most. And as a result, the bottom layer of gases are still gas, but you can see the molecules are closer together. The farther you go up in space, the more farther apart the molecules of gas are. So throughout the atmosphere, it gets thinner and thinner until you get to space where there are hardly any molecules of gas.
I'm going to use this balloon and air pump to help you understand about how the gas gets compressed. So I have a little bit of air in this balloon right now, and I'm going to keep adding more and more air. Now, the rubber of the balloon expands, but the air that's inside is getting squeezed more and more and more, and more air is being compressed inside the balloon. The balloon now has a lot more air, and it is compressed. And it doesn't want to stay like that. If I let go of the balloon, the air is going to come out and expand. I have a few things that you can take out of your bag that will help you explore the air and compressing and things like that a little bit more. So you should have 2 of these syringes, and you should have a flexible tube as well. So please get them out, and you're going to put them together like this. So I have my syringe, and right now, this syringe is not empty, right? This syringe is full of gas. Here's another syringe, also full of gas, all right? So then you can take the tube and you put it on the end and you push it on nice and tight. I'm gonna push 1 plunger in, and now I'm gonna take the other tube and I'm gonna put it on nice and tight, and I'm going to push on this plunger. When I do, this plunger moves because there's air inside. And when I squeeze on the air, it pushes out the other end. It's invisible. We can't see the air, but we know it's there. Just like there's air in our atmosphere. Another fun thing to do is to make a little rocket. Now, in order to do that, we have to use this a little bit differently. So I'm gonna take my plunger out, and I'm gonna make this one out as well. So I've got 2 open syringes like this. I'm gonna take the plunger, I'm gonna put it in just a little bit at the end, not all the way in. Then I'm gonna take the other one, and I'm gonna put it in just a little bit at the end. So now there are 2 tubes full of gas. And when I push down on the table, this tube is going to be pushed out. The gas is going to be compressed, and I'm going to make a little rocket. Ready? Super fun. Earth's atmosphere is really important to life on Earth. The mesosphere burns up asteroids and meteors, and the ozone protects us from UV radiation. Another thing that the atmosphere does, it keeps us warm and cozy. Again, remember that not too hot, not too cold, but just right. So the atmosphere helps keep us warm through something called the greenhouse effect. The sun's light travels to Earth in a ray, right? Remember we talked about light in 4th grade, how light travels in a straight line called a ray. And when the light comes into our atmosphere, it comes down and it hits the Earth and it bounces off. One of the reasons most of the light bounces off is because our planet is made out of water, and water is like a mirror. It reflects the light. So a lot of the light is reflected back out. However, some of it gets trapped in our atmosphere and it gets reflected back down again. And it is changed from light into heat. Remember we talked about energy transfer and conversion in 4th grade? So some of that heat, some of the light and heat escape, but some of it are kept in through the atmosphere. It's kind of like a big blanket that keeps all of the heat inside. Now, that's great. If we didn't have an atmosphere, if we didn't have the greenhouse effect, we would be freezing and there would be no life. However, if we have too much of a greenhouse effect, then this warming gets out of control. And this can happen when we have too much carbon dioxide gas. Carbon dioxide gas is great for plants. They need it in order to make food. And so it's great for them. However, too much carbon dioxide gas helps trap more heat in our atmosphere, making it too hot. Boys and girls, I remember when I talked about the troposphere. Troposphere is where all weather takes place. So these are some things that we look at in terms of the weather. We look at the temperature, air pressure, wind speed, wind direction, precipitation, humidity. I would like you to spend some time over the next 8 days looking at the weather. In your notebook, there's this packet, this little piece of paper, and I want you to look at this, and we are going to put this into your science notebook. All right, Cougars, so get out your science notebook, go to the front page, to the table of contents, and number 6 is going to be weather data, and on mine, it's on page 11, so whatever page it is for you. So I've put it into my notebook, and it says weather data. So what I would like you to do is I would like you to pick a city. You could pick Los Angeles, you could pick maybe someplace where you lived before or where your grandma lives or your grandfather. Pick a city and I want you to track the temperature, the humidity, the wind speed, the wind direction, visibility, air pressure, and any other observations. And I want you to do this for 8 days. I have a second piece of paper I want you to put into your notebook. It's atmosphere questions. Atmosphere questions. So I went back to the beginning of my notebook into the table of contents, and I put number 7, atmosphere information, and mine is on page 12. So I'm going to turn to atmosphere questions, and I want everybody to answer the first question. What is Earth's atmosphere? Everybody must answer that question. And then I want everybody to look at the other 6 questions, and I want you to take turns. Everybody has to answer at least one additional question and write the answer in your science notebook. And of course, you also need to come up with your own question. What do you still want to know about space and weather?